Good morning, people. Now, I'd like to explain more this morning on the details here to give you enlightenment. I know some people may have their doubts about where I'm going with this, talking about the roof first and not. I tell you what, I got about 80% confidence over that the roof started first over the buckled M and N now, M or N. That I have more confidence in the roof first. Yes, my voice is a little different. I have a bit of a throat issue. I was going to put it in a video for you guys. I did put it in a private room, but I didn't post it yet. Tell you what's going on with my throat. Very interesting on its own. Nothing to cry about, just interesting. All right, so let's get some details going. So we have the break here. Okay, I'm sorry, this is a capture that I already wrote on, so I'm not going to be able to clean it all up. So I can change the color though to help us out. So here is that fracture right here. See this fracture? And this wall system kicked out towards us. Kicking out towards us, it was called this rotation like that. Keep following it around. And now put a wall into it. And you can see it pulls the base out, pushes the top in. This is a pivot point. It would have pulled this down in a way had rebar not been engaged inside this column system here. Had rebar not been engaged, across from the left to right. So from this side, let's go to black. So if it had not been engaged this way and this way, this is what? It is a block wall. Okay, this is a I want to say block wall system also, although it's got a very I'm tempted to say it's block wall reinforced block wall, because the way it's not mirroring itself fully, and why I know why it presents as block is that step right there. Okay, that presents as a block wall step, more so than just a solid poured section of wall. All right, they did do a couple of solid pour sections that are pretty beefy, and they would be over color change. Let's go with this. It'd be over here. Now, I want you to take note of the top section here. And this section over here. This is the elevator, part of the elevator shaft system. The service center part of it. And the whole shaft system goes down. Now the steps are here, I believe. The railings going down there. The steps to climb to go in there. Sometimes they can switch steps at this level and allow entrance and egress different ways. It's probably maybe even a emergency egress door there for taking to the stairwell. I think the stairs, if we can't see in this images, are over here. I'm sorry, the balcony's over here. So you go down the stairs like this. And you can enter from these outdoor center into here to enter the stairwell system. Out by the balconies, I believe. So not actually inside the. It's covered, but it's it's got a little bit of a open area that you would enter in. I'm not hating on that. I would say upon further evaluation of this, it still stands that this is flat and the way it was removed. But there's some rotation that took place with this ductwork. And this rotation, I believe, happened after the metal from in the back fell down. The air conditioning unit in the back, the big one, caused the rotation then. Not before, because the flange is still in outstanding shape. Remember the flange. All right. Now, let me show you what I'm working on for you. So what I'm working on for you is the, just not to be distracted, things like that, you guys might wonder, that's just pencil mark. A model. So the elevator shaft is here, this black roofing product I put here for you. We're going to call it, that way you can identify it faster. There are AC units out, comes down, AC units are out here. I'm going to rotate this a bit, hopefully it won't mess up my model much. I'm looking through the camera, so this takes a moment. And here you see that door I mentioned earlier, the door I talked about, and the fold there. And there's just a section of let me look over top of this thing. A section of wall approximately equal with the face of the wall of the structure. So now this is the cutaway. So this is the back wall. Let's get oriented. Hold on. So for orientation, here's the wall I just showed you. Here's the top part. There's some daylight here. All right, in the one I have a slight bit of daylight. We'll look at it. We'll clean up my model also. This is the first rendering model, second rendering model for you guys to observe. And we're going to talk about the floor system that's over here. Why we see this fracture like this, that this is gone. Remember, there's a fracture here, there's tugging here and a bending, and there's a wall system that's blown out here. As you can see, there's a parapet wall, and it goes through like that. And we're going to talk about the panel and the failure system up here. That's Bruce in the background you hear screaming. So in the model, we have this can flip up. There's the door. Now I want you to pay attention to that door. These videos are going to take a while to break down each section for you and each reaction. So I'm going to keep them short, but each one's going to be compounding data. Yes, Bruce, to get you where you need to go. In this video, I think I'll disclose the two things. Multiple things, but there we go. So at any time, you should stop the video if you think you can figure it out. The other thing is, please thumbs up and share the video if you can on Twitter or whatever. All right, so look, we have a buckle here. Look at this buckle. I'm going to move this away, but I want you to observe that buckle there. I also want you to note the gap, the reveal. Reveal, it's called. If you're hanging doors, it's called a reveal. And that reveal is created in this case. It looks symmetrical, meaning equal up. Right? So it has a hinge somewhere about there. And maybe a hinge up here. Usually these commercial doors might have 3 hinges. I don't see the third one. Possibly it was here and that buckle popped off. This is the door jamb. I showed you that in the previous video, or it's number 1 video. You've got to look at this stuff. This is now on the ground, on the deck. The deck has multiple layers of thicknesses. I'm sorry, this floor does. I'll have to remind me to talk about the second layer, multiple layers of material over here. As we go to back to this buckle, I'm going to pause. I'm going to take this off. And I want you to, if you want to look at that door, pause if you want to try to dive into it. Tell me everything you can tell me about that door, including skin color, etc. All right, that's your chance. Now I'm going back to the video for people. The door, you would instinctively initially say, well, it's because this part of the door is folded over, that the impact was from the top, and that caused that buckle here. But again, you can pause. I'm going to say that's more than likely incorrect, and we would need more details on this door, but more details as far as here. Is there a buckle here also? So the door is more twisted, but there's another buckle here. And remember, I need this wall, the floor that wants to, here's a wall here, right? This is that wall system that's out on the, as we look, let me just grab it for you. So I need this wall system that's here, this panel, to move away, rotate away, And I also needed to kick in a wall down here. So I need a force that's going to rotate like this from this corner, basically. How the heck can I get that? Because when it's falling away, rotating away, it's dropping away also. It's going away from, say, here's the door, right? Let's look at it this way. And here's my my wall. I'm going to, see that, don't get confused. I'm not talking about this wall, all right? No. I'm exaggerating this section here, that's under here. It's against this wall here. Yeah, my connections are wrong. Hold on. So I'm exaggerating it. And then come out. Here's a doorway. And then I want you to do that. It's not much of a door, of a wall system. This one here. But it is, right? If I turn this way, it has a, if you can see it now, it has a little bit of a panel to it. So here's a door down here against this wall. It's down there below. We're just cutting away, looking through it. So I only have a little bit of wall here and then this panel. But I'm also still insisting it must push in to the elevator shaft based on the image I presented. Let's find that image. And I want you to tell me, you can pause at any time and beat me to it. So this presents as, see the plane, the shadow lines, the plane, it shows that this section here, is set back further than this section. And this section is in place. I believe some rotation took place on it. Not much, but a little bit. So much so that it buckled this door. It just didn't fall away, it buckled the door. And it's not just, and there's an action that folded over also. Well, we're sort of looking at the action that folded over. There's a rebar right here. And it's amazing, this rebar. The rebar is stripped of concrete hanging onto it. There's nothing else above to impact it. There's nothing else above to impact this rebar. So it was strictly in tension. So it had a hell of a bonding ability, or somewhat. And they look like 90s. They're both parallel. When this went down, it didn't create those 90s. Right? It didn't create 90-degree angles. So what I'm driving at is these 90s right here were not created by the building going down. It would be a 90-degree turn. It'd have to hold the metal still while you bent the metal. They didn't happen there. Those are the L-shaped. Those are the 90s. The engagement probably goes to the end of the, like that, and then to the wall system. And so these 90s probably are these 90s. Okay, so then you have a beam going across like that. And let me put my door in now. And then here's the door. And here's some block, a fill block. Okay. As this rotates down, because it's falling downwards, because the pad it sits on a pad. It's now somewhere approximately, let's just do that around this end over here. It starts to rotate down because of failing through punching shear. I believe at the column that I described to you, columns, it would be front, right facade, and the 9.1 and this guy here, the one that's behind 9.1G. So we get our downward downward direction, but it's more like, so let's see if I can give you a pivot point. Here's a door, right? There's the wall, this wall here. Okay, that's that plane there, if you will, or you can choose it going back if you like to help you clarify. So let me change one more color for you. Let me do this in green to make it stand out a little more. So there's your, and this ties back. And let's give you a different rebar color. Blue color here on rebar. Tying it back into the existing structure. It does not collapse. This is not collapsed. All right, this is what we're looking at. It's over here, not collapsed. Section in the background I'm writing, so it helps you out. I know you might have to look at this for a couple of times. This is the floor. So this is the roof floor. Floor roof. All right. Also ceiling maybe down below. I don't know what they have below it. So now it's the infill block and this is the door. Let me put a little doorknob here. All right. Unlocking doorknob. Maybe it's locking. I don't know. So we get this crinkle, this folding like that. As it folds down, what folds it down? Well, when this rotates away, new color, and new color again. It's gonna blend. I'll go with red, or whatever that is. Okay, this is being held on. This section here, held right here. That's the rebar what I showed you. As it goes down, it folds this door. It compresses this block to some degree, pushing into the door, folding this, compressing this door a bit. And I can't quite tell. I'm going to delete this all now. See, whatever you're looking at now, memorize it. Or remember the timeline in the image video, and I'm going to now erase it. I know it's some work, but you guys just remember what you're looking at. Oh, for clarity, this is the end wall. Remember, it's just the end wall that it's the return wall. It's just a return wall that goes the other direction. I think I can just do this without messing this up yet. Okay, turns out I could not do it without messing it up. I had to erase it. So the return wall is this wall here. All right, there's the punching shear zone, I believe, the failure. We need to find that repair location. I want you to note that ductwork that I'm always talking about with the flange is about 90 degrees. 90 degrees to the wall system right here at 90. And now at one point we see it sort of like this. And you're like, well, that's not 90 degrees. The point is, it didn't get turned to that position. Look, it's beyond it's in a different position at that point. It didn't get turned from there. It appears to be the flange, not because you're inside the walking zone inside here at this point. So I don't believe they put that ductwork in there and they flanged it here. Possible. It doesn't change anything, and I would have to count these segments. So there's 1, 2, and then this little segment here to confirm that. But I think it's just the 2 segments we see here. So they flanged here, and then they switched to they flanged at the wall, flanged, and they went to a new system. If this wall was to rotate before the rotation took place, rotating meaning repositioning of this flange like that, and this entire ductwork system like that, then we would have a bent. The flange would have this would have been flange, and or the section would have been more distorted by itself. But we have this. We have them both moving at the same time. This whole configuration, we have it pretty much. This configuration here just shifted to be in a new position, which is, it's down a little bit. It's down on an angle a bit, so that's going to count as, Y. And then it's like that. This. But remember, this went down. And when this went down, it pulled this. And I believe at that point, it's been going down secondary, that it rotated, pulling down into the abyss. It rotated the system, shifting it, creating some defects up here that possibly wouldn't have been there. This metal is not your lightweight house metal. Okay, so here we go. We have a column right about here. I believe that's our initial punching shear. There's another column out here. Now I want to talk to you about that wall. Remember, we see that little bit of what appears as black, but in reality it might be, it's all this parapet material going up the wall initially, and then they counterflash it. So here we have the fracture here, which indicates the rotation. Now, I don't believe this wall is in plane. I believe that, remember, it kicked out, that it kicked out a bit. So what would help with that kick out is that and let's talk about this real quickly, and then I'm gonna end the video because it's a lot of data I'm trying to share with you. So why is this flat over here, and why does this have a shelf? Why is it kicked out? Why? That is, this just doesn't make sense to the normal viewer. Why? Looking at the elevator, looking at this is an elevator shaft. Elevator shaft. There will be no floor continuously going across here. Looking over here, we see that they have 4 number 10s going across the system and tying across. We see some rebar here, and it goes across. All right, it goes across. Let me profile that a little different color for you. So it goes across. But over here, it stops. It butts. Because the elevator shaft, you can't have the floor in the way of the elevator. So this section is only engaged at the wall. But this section, all of the engagement changes. It becomes part of a floor system out here. And when it goes down, the profile that's left behind is like this. Okay, let's leave that because I believe that. Let's leave that. And I'm going to do another color over top of it to highlight it for you. That is what we see there in the one image. With the floor system sticking out further. So then we have this floor system again, gone. So, but they did some rotation, some tugging here. Remember, so it tugged there. So it held on. The reinforcement, it was tied into that wall system, it tied into a column right here. Held on, columns here. Oops. Sorry guys, the porch sticks out beyond this where we're looking, so the porch is out here like this. So I should have, wait a minute. It's T there then. It's larger than I'm giving it respect for. Because here's a beam coming across this direction. So it's either like that, or it's singular or doubled up, which doesn't make sense. Nobody's going to make 2 columns side by side there at that time. So the time period. So we have this tugging. It held on here. And then we need a rotation, and we also need to drive down. Remember, so this wants to, so it's driving down now, I believe through punching shear here, failure. The pad still is resisting, though. It doesn't want to go down. We get a rotation here, but part of that rotation was caused by that beam that I showed you with the hooks, like that. Then it held on to that wall system. The wall system, I don't know how it was tied to the floor. Came over there. So here's that. Right here we have a tug. I'm sorry, we have a fracture, a rotation point, and a tug here. Tugs away, pulling out that beam to some degree. When it does that, this wall system, part of the floor system doing the tugging, causes another secondary fracture there. I believe there's another one here. But I still have this going in a bit. I might have to reevaluate it. Is it in? I thought I saw it. In. It would be convenient for me to say it's not in, okay? Convenient. Looking at the door jambs and everything else, it did look pretty plumb to me, and I really tried. I can't see behind the door, but I used that setback. Maybe I'm seeing ghost. It would be very convenient for me not to have to push this in. But not getting rid of convenience, I can get it done because of the reinforcement of that going back into the building, those 90s. Remember the 90s? They held on. They held on. The concrete held on. It rotated and then it stripped off the 90s. It literally just burst off the 90s. So there was some time that it held on. That the floor system and this system did some anchoring back to the structure here. That might have been bought some time doing this creaking people said they heard and everything else. These 90s might be your time to get you, if you want to add creaking and heard noises and banging and whatever. This could be your time where this thing is acting in a hanger capacity and holding it. These things are holding it because they're totally stripped. If the floor just fell away, it can support that little cantilever, no sweat. Just like this cantilever here is being supported when we see it after the fact. No sweat. But those things being stripped, they're a red flag for me going, wow, that was a lot. I do rebar pull-out test. And you don't see concrete pull out like that. You see the rebar start sliding, things like that. But this is the concrete now. This would be like a concrete pull-out test. Grabbing hold of the concrete and start pulling on the whole to test it, rebar pull out times 2 of those piece of steel. And it just had so much stress in it that, remember, when it starts deflecting, I state that, remember I showed you this, I always give you, I stack data. It takes me a long time to get to you. When I showed you when they were load testing concrete samples, that I state that they split. And this will explain the samples down below, that when everyone calls it a shear fracture, I'm stating that the deflection, right, this deflection that takes place, I really want to draw it in here like that. Deflection that takes place puts a superior stress on top of into the steel and the bond strength of the concrete. And when that happens, when it finally meets its maximum, they just separate and you'll see a fracture come down here first. It lines up with the steel each time, guys. You can't just ignore that this is one of the first things you see propagate. If you slow down the films, this is the first you see propagate. And I went the wrong direction. Usually propagation is that way. It's this direction. And then, now the load then is taking into the concrete more so. And it will be random how the concrete is composed. But it may start, here, the spans, where the loading depends, here. And then you'll see it work its way right directly back to the point load. This stress is like that. So when you see the steel here, and they're both unmarried from the concrete, if you guys are familiar with my terms, they're no longer married with the concrete. That's because that stress was so great at that point that it yeah, I'm trying to be clean with this because I try to teach by make people remember, and I come up with some profanity and profound words. So it then breaks bond with the concrete. It ejects it off of the concrete. The stresses can no longer be held. I want to do a video for you showing you basically a few things. How rust can eject the concrete off of it. To say we no longer have love. There's a few other things, but you know what? I don't want to go down that line yet. That's going to be on the other channel anyway. So rounding it up with the model that we still will see more of, it will still be here. This roof is actually lower than this roof over on the edge. Can't see through this camera. Than this roof. There's your door. There's that steel I talk about. It's inside here that comes across. The steel is anchored back to here. When it's done, that steel we observe as across the door, and the door's over here. You see what you can learn from a model? So the steel was in line this way, but now the steel is across the flap of the door over here. So this starts telling us our direction already at the highest level we can find. Our steel is deformed over here. It needs a force to put it over there. So if you start tracing it back here, we're starting to get a profile of our critical shear zone and a failure outside the critical shear zone over here, perhaps. I got to triangulate with measurements and all, but I'm still working on a few things for you. here's the floor system. And in the floor, I just penciled this in. This is how it looks. Just go back there like that. This is how the floor extends out. There's rebar. There's rebar going from here all the way across, remember? Rebar. No rebar there. That's an elevator shaft. It is just void. It's empty. It's just up to the wall there. The door would be over. I think there might be another door there. It might not be. Okay, so I know someone made fun of, next thing you know, you're going to say it's the building down the street. So I trolled the person back saying that he said that someone commented saying that the next thing you're going to say it's the building down the street that did it. I'm like, you know, I called him stupid. I said, stupid. They've already said that in the very beginning. Building down the street did it. That's literally the building next door. It's down the street. They've already said it was causing it, the vibrations. So you trolled yourself, or you're not paying attention. Okay, so they were trying to make fun. First is the planter boxes. First is the dip pool. He said swimming pool. And now it's the roof. He said, then next you know it's going to be the building down the street. And I'm like, yeah, they've already gone down that line. Okay, so he trolled himself. I'm going to end this video, but where's my sample? This is what you're getting now. Now you know the way it takes me a while to get you guys all the data, but this is just data stacking for you. Yes, this model is modular. I can take it apart and add things to it. Even that flap's going to be modular, maybe. Just wanted you to see it. Take care. Love you. Bye.